ago. My name is Muhammad Nafiq bin Muhammad, contact number 1810326. For my part, I will talk about the MEMS capacitive sensor. MEMS is a chip-based technology that known as a microelectromechanical system. Capacitor is the ability of an object to hold an electrical charge, while capacitive transducer measures change in this electrical charge. Sensors are composed of a suspended mass between pair of capacitive plates. When heat is applied to the sensor, the suspended mass creates a difference in electrical potential. The difference is measured as a change in capacitance. So this is the geometry from the space claim, and then this the total information that happen during the process.
Assalamualaikum, my name is Nur Izu Azira binti Cik Azhari. Today I would like to present about MEMS fabrication simulation. Here is the layout we are using in MEMS Pro software to that resemble a mask design for capacitive sensor. We have used 5 materials: silicon oxide, polysilicon, silicon nitride, and gold in the layout with different width and height for every shape. Here, there is also a material database for the pure silicon, gold, and silicon nitride to be filled in while listing the material in the box on the bottom right. For next slide, here's how to make a 3D model step by step. We declare the stage by looking at the article we utilize in order for the 3D to fit perfectly in the piece. To ensure that this procedure is complete, there are 12 processes, including the etching process, deposit, sacrificial etch, and others. According to the type of comment and thickness required for each procedure, different materials are used in each. For this process, we take a picture from the top to easily see what material is used for each process. After that, the final 3D model is created after the process is complete. The top view 3D model for this capacitive sensor technique is on the bottom left, and the final cross section is adjacent to it. Thank you.
Assalamualaikum, my name is Suhaizam. In total, we come up with 4 potential top view concepts: graphical representation for geometry in space claim and design modular for mesh and input data, and boundary condition can be all found. We can only move or rotate along one axis at a moment in space claim and a design model. Each design has its own set of measurement by thickness and assignment. So, the step for meshing is the process of breaking up an object continuous geometric space into 1,000 or more discrete shapes in order to describe its physical shape. An accurate 3D CAD model can be created with a higher detail mesh, enabling for high fidelity simulation. Each input and boundary condition will also have a fixed support, force, or pressure applied to it as a result of the design. Using fixed support, we can see that all degree of freedom are constrained and the thickness is affected the architecture too. Thank you.
This is our result that occur when input pressure are put on the surface. The graph shows input pressure versus total deformation, which the pressure value 0.001 until 0.004 Pascal. There are 5 different materials that we use in this analysis, which are bronze, brass, copper, concrete, and zinc. As we can see on the graph, the total deformation is proportionally increased with the input pressure. Here we also can see that copper and bronze almost have same value. The highest value of total deformation on the graph is concrete, which the value is 0.83391 meter. So we conclude that the concrete have highest susceptibility and bronze have lower susceptibility.
MEMS capacitive sensor for campus sustainability. Most institutions are working to make campus lighting more sustainable and efficient. Most lighting facilities on campus has been upgraded to light-emitting diode technology (LED). This enhancement will greatly cut carbon emission, encourage cost saving, and restrict waste. One among the most cutting-edge and environmentally concerned. This campus lighting can benefit college and lecture hall as well as park, sidewalk, and parking lot. This will benefit both students and college staff. Poor air quality is a global environmental challenge, and improper waste management will result in a slew of environmental issues such as water pollution, air pollution, and health issues. MEMS capacity sensor can be used to develop new sensing principle, design and simulation, fabrication and integration technologies, new smart sensor and device, IoT, which is Internet of Things, sensor module, and testing and characterization of such system for campus sustainability.